Hello everyone, this is Chinnaiah Kalpana here. In this video, we're going to see a problem from partial differential equation. So let's get going. Problem: form the partial differential equation by eliminating the arbitrary constants from z equal to a square x plus b square y plus ab. We are given an equation z equal to a square x plus b square y plus ab, right? Consider it as equation number 1. And we are asked to form a partial differential equation by eliminating the arbitrary constants a and b from 1, right? So we'll just partially differentiate 1 with respect to x. See, first we'll see the detailed way partially differentiating 1 with respect to x, and later we'll see the shortcut, just by reducing the number of steps. So just apply dou y dou x on both sides of 1. Since we are partially differentiating with respect to x, so we'll treat y as constant, and here z is a dependent variable and x and y are independent variable, or we can say z is a function of x and y, where x and y are independent variables and z is a dependent variable. This gives us, coming to the problem, this gives us dou z by dou x equal to partial derivative of first term plus partial derivative of second term plus partial derivative of last term or third term. Right? Since we are having notation dou z by dou x equal to p, let's replace LHS part by p. You'll get p equal to constant a square into dou by dou x of x plus partial derivative of a constant with respect to x is 0. Since we are partially differentiating with respect to x, so we'll treat y as constant, right? So here we are having b square and y, which is treated as constant, so the partial derivative of constant with respect to x will be 0 plus partial derivative of a constant with respect to x 0, which gives us p equal to a square into partial derivative of x with respect to x is 1, right? So you got p equal to a square, or you can write it as a square equal to p, and from this you'll get a equal to square root of p, right? Consider it as equation number 2. Now let's partially differentiate 1 with respect to y. Partially differentiating 1 with respect to y. Okay. Just apply dou by dou y on both sides of 1. Here we are partially differentiating with respect to y, so we'll treat x as constant, which gives us dou z by dou y equal to dou by dou y of the first term plus dou by dou y of the second term plus dou by dou y of third term. Since we have a notation dou z by dou y equal to q, right? So let's replace the first term, the LHS part, by q. You'll get q equal to partial derivative of a constant with respect to y is 0 plus constant b square into partial derivative of y plus partial derivative of a constant with respect to y is 0, which gives us q equal to b square into partial derivative of y with respect to y is 1, which gives us q equal to b square, or we can write it as b square equal to q, which gives us b equal to square root of q. Consider as equation number 3. Now observe 1, 2 and 3. So from these 3 we can say that by observing 1, 2, 3, we can say that by replacing 2 and 3 in 1, the arbitrary constants gets eliminated, right? See, a can be replaced by if a square, or if a can be replaced by square root of p, the arbitrary constant a gets eliminated. Here also b gets eliminated using 3. and AB gets eliminated using 2 and 3. Right? Let's see that now. We have 1, it is z equal to a square x plus b square y plus AB. Substitute 2 and 3 in 1, right, which gives us z equal to, replace a by square root of p, and since a equal to square root of p and b equal to square root of q by 2 and 3, right, replace a and b. See, square root of p whole square can be written as p power 1 by 2, since square root of a equal to a power 1 by 2, right? So you can write square root of p as p power 1 by 2 raised to power square. Since a power m whole power n equal to a power m n, so you can write this as p power 1 by 2 into 2, where 2 gets cancelled, you'll get p, right? So this gives us z equal to px plus, likewise, square root of q whole square will be q. We'll get q y plus square root of p into square root of q, right? Which gives us z equal to px plus qy plus square root of p into square root of q is square root of pq. See, square root of p can be written as p power 1 by 2 and square root of q can be written as q power 1 by 2. A power m into b power m can be written as ab power m, right? So you can just write it as pq power 1 by 2. Again, a power 1 by 2 can be written as square root of a, right? So you can just write it as square root of pq. Okay. So it does not involve any arbitrary constants. Therefore, z equal to px plus qy plus square root of pq is the required partial differential equation. Which completes the problem. Now let's see the same problem by reducing the number of steps. Given z equal to a square x, it's z, plus b square y plus ab, considered as equation 1. Now partially differentiate 1 with respect to x. We'll get dou z by dou x equal to a square into partial derivative of x with respect to x is 1 plus partial derivative of a constant with respect to x 0 plus partial derivative of ab with respect to x is 0, which gives us, we have a notation dou z by dou x equal to p, so let's replace it by p. You'll get p equal to a square, or you can write it as a equal to square root of p. We have considered as equation number 2, right? Now partially differentiate 1 with respect to y. We'll get dou z by dou y equal to partial derivative of a constant with respect to y is 0 plus partial derivative of plus b square into partial derivative of y with respect to y is 1 plus partial derivative of a constant with respect to y is 0, which gives us, here we have notation dou z by dou y equal to q, just replace it by q, you'll get q equal to b square, or we can write it as b equal to square root of q. We have considered as equation number 3, right? Now observe 1, 2 and 3. From this we can say that by replacing 2 and 3 in 1, or but just by substituting 2 and 3 in 1, we can eliminate the arbitrary constants to form the required partial differential equation, right? We have 1, that is z equal to a square x plus b square y plus ab. Now substitute 2 and 3 in 1, that is a equal to root p plus b equal to root q. Then you'll get z equal to a square root p whole square x plus b square into y plus square root of p into square root of q, which gives us px plus qy plus square root of pq. That is z equal to px plus qy plus square root of pq is the required partial differential equation, which completes the problem. So it does not involve any arbitrary constants. Well, we have seen a problem from partial differential equation in this video. I hope you'll understand. We'll see you in the next video. Until then, bye.